Good morning everyone. Okay, today we are going to do question 18 of miscellaneous exercise chapter number 4. If x, y, z are non-zero real numbers, then the inverse of the matrix. Okay, given matrix A is x 0 0 0 y 0 0 0 z. Now we have to find inverse of this given matrix. And as you know, to find inverse of given matrix, first of all we have to decide that matrix is singular or non-singular. That means first we have to find determinant of A, and the value is non-zero, that means not zero. Then the inverse exists. Okay, so first of all we find determinant of A. So elements are x 0 0 0 y 0 0 0 z. Okay, first element is x, so we can hide first row, first column. So remaining determinant is y 0 0 z. So yz minus 0 plus 0. We can't expand brackets term because multiplication of any term with 0 is 0 and last term is also 0. So answer is x, y, z. That means determinant of A is not equals to 0 and therefore A inverse exists. Okay. Now to find A inverse, we need adjoint of A, and for adjoint of A, we have to find out cofactors of all elements. That means we have to find out A11, A12, A13, A21, A22, A23, A31, A32 and A33. Now to find element A11, we have to hide first row and first column. So you can hide like this. So remaining elements are y0 0 z, and we solve this determinant. Then answer is yz. Okay. Now for A12, we can hide first row and second column. So 0 minus 0. So answer is 0. To find A13, we can hide first row, third column. So answer is 0. To find element A21, we can hide second row and first column. That means second row and first column. So 0 0 0 z. So 0 minus 0. So answer is 0. To find element A22, we can hide second row, second column. So yz minus 0. Sorry, xz. So answer is xz. To find element A23, we can hide second row, third column. So 0 minus 0. So answer is 0. To find element A31, we can hide third row and first column. That means third row, first column. So 0 minus 0. So answer is 0. To find element A32, we have to hide third row and second column. So 0 minus 0. So answer is 0. A33, that means third row and third column. So answer is xy. Okay. These all are minors of given elements. And we have to find out cofactors. So as you know, we have to change sign of these four elements. because the addition of this number is odd. 2 plus 1 3, 2 plus 1 3, 2 plus 2, sorry, 2 plus 3 5, 3 plus 2 5. So we have to change the sign of these four elements, but all these elements are 0, so we can't change the sign. Addition of this, all elements are even numbers, so we don't need to change the sign. 1 plus 1 2, 1 plus 3 4, 2 plus 2 4, 3 plus 1 4, and 3 plus 3 6. All are even numbers. Okay. Now to write adjoint of A. This first row is converted into columns. So YZ 0 and 0 becomes first columns. YZ 0 0. This second row becomes second column. So 0 XZ 0 and 0 0 XY is third column. Okay. So we find adjoint of A. Okay. Now to find A inverse. A inverse is equals to 1 upon determinant of A into adjoint of A. So 1 upon determinant of A, so we can write x, y, z. Now adjoint of A. So YZ 0 0, 0 XZ 0, 0 0 XY. Okay. Okay, now we are going to do question 19. Let matrix A is equals to 1 sin theta 1 minus sin theta 1 sin theta minus 1 minus sin theta 1, where 0 less or equals to theta less or equals to 2 pi. That means theta lie between 0 and 2 pi. Then given four options are: determinant of A is equals to 0, determinant of A belongs to open interval 2 to infinity, determinant of A belongs to open interval 2 to 4, and determinant of A belongs to closed interval 2 to 4. So we have to find out determinant of this matrix. So first, determinant of A. So 1 sin theta 1 minus sin theta 1 sin theta minus 1 minus sin theta 1. Okay. Now we expand it. So 1. So we hide 1. That means first row and first column. So 1 1s are 1 minus sin theta into minus sin theta. So minus sin square theta. So here plus sin square theta minus second term is sin theta. So we hide sin theta. That means first row, second column. So minus sin theta minus sin theta into minus 1. So minus sin theta. So here plus sin theta plus 1. So we can hide 1. That means first row, third column. So minus sin theta into minus sin theta. So sin square theta minus 1 into minus 1. So here plus 1. Now we solve it. So 1 plus sin square theta minus sin theta into minus sin theta plus sin theta. So here 0 plus sin square theta plus 1. So sin square theta plus sin square theta. So 2 sin square theta and 1 plus 1. So 2. So now we have determinant of A is equals to 2 sine square theta plus 2. Okay. And we have options. Determinant of A belongs to interval. So we have to find out range of this term. 2 sine square theta plus 2. Okay. Now, as you know, in 11th, we learn range of sine theta is closed interval minus 1 to 1. So, we can write like this. Minus 1 less or equals to sine theta less or equals to 1. But for determinant of A, we require sine square theta. And we learn in 11. So, if sine theta lie between minus 1 to 1, then sine square theta lie between 0 and 1. Okay, sine theta is lie between minus 1 to 1, and sine square theta lie between 0 and 1. We learn much in 11th standard in chapter 3. Okay, now we require 2 sine square theta. That means coefficient of sine square theta is 2. So we have to multiply all terms with 2. So 0 into 2, 2. Sorry, 0 into 2, 0. 2 sine square theta less or equals to 2. Now, we need plus 2. So, we add plus 2 in all steps. So, 0 plus 2. So, 2. 2 sine square theta plus 2. And 2 plus 2. So, here 4. So, we can say that 2 sine square theta plus 2 belongs to closed interval 2 to 4. 2 sine square theta plus 2 lie between 2 and 4. 2 is also and 4 is also taken in range of 2 sine square theta plus 2. So, determinant of A belongs to closed interval 2 to 4. Okay. So, in answer is option D. Okay, answer is option D. If you want to write down, then write down this. Otherwise, I will give you PDF. Okay. Now, we are going to do exercise 4.2. Exercise 4.2. And in exercise 4.2, we have to prove all sums without expanding determinant. So, we have to use properties of determinant. Okay, we have to use properties of determinant. We learn all properties of determinant, but to start before exercise 4.2, I will explain you again. Okay. What is property 1 says? Property 1 says the value of determinant remain unchanged if rows and columns are interchanged. That means if one matrix is 2, minus 3, 5, 6, 0, 4, 1, 5, minus 7. Okay. After solving this determinant, we get minus 28. Okay. And property 1 says if we interchange all row into column, that means determinant became like this. 2, minus 3, 5. First row became first column. Second row became second column. And third row became third column. Then determinant remained unchanged. That means if we solve this determinant, then answer is also minus 28. Okay. This called property number 1. Okay. Now, property 2. If any two rows or columns of determinant are interchanged, then signs of determinant change. Okay. In second property says that if two rows or any two columns are interchanged, that means if in this determinant first row and third row are interchanged, that means R1 to R3, that means first and third row are changed. That means first row became third row and third row became first row. So determinant is like this. Second row is as it is. Then determinant change. That means if this determinant has answer minus 20, then answer of this determinant is plus 28. Answer of this determinant is plus 20. Okay. If all rows are converted into columns, then answer remains same. That means determinant remains same. But if any two row interchange, then determinant change. That means minus, then answer is plus, or if answer is plus, then here minus. Okay. Same applicable on column. That means if I can write down C2 transfer to C3. That means second column and third column are interchanged. First column as it is. Second and third column change. Then answer is 28. Okay. Now, third property. If any two row of a column or determinant are identical, then the value of determinant is 0. That means if in determinant any two row or any two columns are same, that means like this. Here two rows are equal, R1 and R3. So answer is 0. Don't need to expand determinant. Answer is 0. And if you expand, then answer you will get 0. Okay. So in third property says that if any two rows or any two columns are equal, then the value of determinant is 0. Okay. And last property. Property 5. If some or all elements of a row or a column of a determinant are expressed as the sum of two terms, then the determinant can be expressed as the sum of two determinants. Okay, I can explain by example. Okay, determinant is like this. Here, first row is addition of two terms. So, we can write this determinant like this. X, first element X, X and Y. So, first row X, X, Y. Second and third row as it is. Plus. Now, A, B, C. So, I can write A, B, C. Second and third row are as it is. Okay. If we solve this determinant and solve this determinant and this, and after add, then answer is same. Okay. This property is also applicable on column. And we also learn about Now we are going to do exercise 4.2. Using the property of determinants and without expanding in exercise 1 to 5. Prove that. Okay, first sum is x, y, z, a, b, c, x plus a, y plus b, z plus c is equals to 0. Okay. So without expanding, that means in general we solve determinant by like this, x as it is. After that x is hidden like this. Then multiplication of these two terms minus multiplication of these two terms. And then we solve equation, then we get 0. But now we have to prove the value of this determinant is 0 without expanding. That means use of determinants property. Okay, so we can take this determinant as left hand side. Okay, now we see that first column is x, y, z, second column is a, b, c, and third column is x plus a, y plus b, and z plus c. So we can convert first column into c1 plus c2. That means now c1 column becomes c1 plus c2. So we can add second column in first column. So our determinant becomes x plus a. Here y plus b, and here z plus c. Okay, second and third column as it is. Now we can see first and third column are same. That means C1 is equals to C2. And we see property number 3. If two rows or two columns are identical, that means elements are same, x plus a, x plus a, y plus b, y plus b, z plus c, z plus c, then determinant is 0. So answer is 0. And so we can write LHS is equals to RHS. Okay. So we prove without expanding value of this determinant is 0. Okay. Okay. For this sum, we have also another method. Okay. LHS is equals to okay. Now, for this determinant, I can use property number 5. That means in third column, elements are addition of two terms. So we can write also like this. First column as it is. Second column as it is. And third column is here. X, y, and z. Plus, again, first column as it is. Second column as it is, and third column is A, B, and C. Property 5. Okay. Now, in this determinant, C1 is equals to C3. And in this determinant, second column and third column same. So, value of this determinant is also 0. And value of this determinant is also 0. So answer is 0. So we can do this sum by two methods. Okay. So I want to say you that તમને જે મેથડ પ્રિફર હોય એ મેથડથી સમ કરી શકાય. ઓકે, બટ વી કેન યુઝ properties of determinant, not expanding. determinant ને expand કરવાનો નથી. ઓકે, એન્ડ ક્લિયર ઇન યોર માઇન્ડ ધેટ જ્યારે બી રાઈટ સાઈડ પર આન્સર 0 લાવવાના હોય ત્યારે આપણી ટ્રાય એવી હોવી જોઈએ કે કોઈ બી બે રો અધરવાઇઝ કોઈ બી બે કોલમને એડ કરીને અધરવાઇઝ સબસ્ટ્રેક્ટ કરીને સેમ એલિમેન્ટ લાવવાના. ધેટ મીન્સ બે રો સેમ બનાવવાની, અધરવાઇઝ બે કોલમ સેમ બનાવવાના. આન્સર શું આવી જાય? 0. ઓકે, વધારે સમજાઈશું વધારે ક્લિયર થશે. આ બેમાંથી કોઈ બી મેથડ તમે એપ્લાય કરી શકો. ઓકે, if you want to write down, then do this one. Okay, now we see second sum. Okay, second sum is a minus b, b minus c, c minus a, b minus c, c minus a minus b, c minus a minus b, and b minus c is equals to 0. Okay, first we take left hand side. So LHS is equals to, and we want answer 0 on right hand side. Again repeat, to get answer 0 we tried 2 rows are identical, otherwise 2 columns are identical. That means we have to add any 2 rows or we have to subtract any 2 row otherwise column. Okay, now we can see if we add first and second column, that means R1 transfer to R1 plus R2, then we get A minus B. In first row we add second row, that means corresponding element, so A minus B plus B minus C. Here B minus C plus C minus A, C minus A plus A minus B. Second and third row as it is. Now we have minus C plus B, minus C plus C, minus A plus A. So we get A minus C. Here B minus C. Here C minus B. Okay, second and third row as it is. Now we can see first row is A minus C, B minus A and C minus B, and third row is C minus A minus B and B minus C. So we common minus sign from first row, so we can write here C minus A becomes, sorry, A minus C became C minus A. Here A minus B and here B minus C. Second and third row as it is. So minus 1 as it is. Here first row and third row are same, that means identical. So value of this determinant is 0 and we write R1 is equals to R3. So minus 1 into 0, answer is 0. Okay, again repeat, from first row we can take minus 1 common out. So here C minus A, here A minus B and here B minus C. So first and third row are identical. That means same. Corresponding elements are same. And therefore by property 3, value of this determinant is 0. Minus 1 into 0 is equals to 0. So we can write LHS is equals to RHS. Okay. This sum is also do by like this. You can add second and third row. That means R2 transfer to R2 plus R3. Otherwise, R1 transfer to R1 plus R3. Okay. You can also apply this all operations on column. That means C1 transfer to C1 plus C2. Otherwise, C2 transfer to C1 plus C3. Otherwise, C3 transfer to C1 plus C3. Okay. If you want to write down, then write down. Otherwise, I will get you PDF. Okay.